Number one, differentiate x minus 3 times x squared plus 5. We can name the function. Let's call it y. Let y be equal to x minus 3 times x squared plus 5. That's the same as x cubed plus 5x minus 3x squared minus 15. That means dy dx will be equal to 3x squared plus 5 minus 6x. If you differentiate minus 15, you get 0. And we can rearrange that as 3x squared minus 6x plus 5. That's dy dx. Now we go to number 2. A curve is given by y equals 8x plus 27 over x squared. Find an expression for dy dx. That's simply saying that we should differentiate y. Now we can write y as 8x plus 27x raised to the power minus 2. And that means dy dx will be equal to 8 plus 27 into bracket. When you differentiate x raised to the power minus 2, you get minus 2x raised to the power minus 3. And that's 8 minus 54x raised to the power minus 2, which means dy dx is equal to 8 minus 54 over x squared. Now to number 3. If 3x squared plus 2y squared plus xy plus x minus 7 equals 0, find dy dx. This is an implicit function. So when we differentiate, we have 6x plus 4y plus xy is a product of two functions. So you put down the first, which is x, differentiate the second. When you differentiate y, you differentiate that y as if it is x. So you get 1. And because it's an implicit function, you attach dy dx to the result whenever you differentiate a y. Plus put down the second, which is y. Differentiate the first, which is x. When you differentiate x, you get 1. Plus when you differentiate this x, you get 1. And when you differentiate minus 7, you get 0. So that will be equal to 0. Let me take that again. When you differentiate 3x squared, you get 6x. Differentiate 2y squared, you get 4y. When you want to differentiate xy, you take it as a product. It's a product of two functions. So you put down the first, differentiate the second. The second is y. When you differentiate y, you will get 1. Because it's an implicit function, you attach dy dx to that result. Plus, put down the second, which is y, differentiate the first, which is x. When you differentiate x, you get 1. Plus, when you differentiate this x, you get 1. And the derivative of minus 7 is 0. So the whole of that will be equal to 0. So when you differentiate a y in an implicit function, you attach dy dx to your answer. So what do we have? This is simply the same as 6x plus 4y plus x dy dx plus y plus 1 equals 0. And that simply means 6x plus 4y plus y is 5y. 6x plus 5y plus 1 plus x dy dx equals 0. And that simply means x dy dx is equal to minus 6x minus 5y minus 1. If you take all of this to the right hand side, and that simply means that's the same as minus into bracket 6x plus 5y plus 1. Or let me even leave it as minus 6x minus 5y minus 1. So dy dx is therefore equal to minus 6x minus 5y minus 1 over x, and that's dy dx. Now we go to number 4. The equation of a curve is given by y equals x into bracket 3 minus x squared. Find the equation of its normal at the point where x equals to 2. If y equals x into bracket 3 minus x squared, I can write that as 3x minus x cubed. That's the same as y equals 3x minus x cubed. So that's just by opening the brackets. And now let's sketch the curve. If this is the curve, the point on the curve is 2. At that point where x is equal to 2, we need to find the y coordinate. We know that the function is y equals 3x minus x cubed. So at x equals 2, y will be equal to 3 times 2 minus 2 raised to power 3. And that's the same as 6 minus 8, which means minus 2. So that means at the point where x is equal to 2, y is equal to minus 2. Now, we need to find the gradient of the tangent at x equals 2. Let's sketch the tangent. That's the tangent. We want to find the gradient of the tangent at x equals 2. Let the gradient of that tangent be m1. The gradient of that tangent is m1. To find the gradient of a tangent, which is m1, we need to find dy dx. We need to find the derivative of y. Y is equal to 3x minus x cubed. So dy dx will be equal to 3 minus 3x squared. When you differentiate 3x, you get 3. When you differentiate minus x cubed, you get minus 3x squared. So now at x equals to dy dx is equal to 3 minus 3 into bracket 2 square, and that's the same as 3 minus 2 square is 4 times 3, 12, which is minus 9. Therefore, the gradient of the tangent to the curve at x equals 2 is minus 9. I've called it m1, so that therefore means m1 is minus 9. Now, m1 is equal to minus 9. Now we want to find the equation of the normal to the tangent at x equals 2. Let this be the normal. The normal to the tangent is perpendicular to the tangent. Let me call the gradient of the normal m2. And we know that when two lines are perpendicular, the product of their gradients is minus 1. So that means the gradient of the normal multiplied by the gradient of the tangent is minus 1. m1 times m2 equals minus 1. And that means m2, which is the gradient of the normal, is minus 1 over m1. And that's minus 1 over minus 9, which is equal to 1 over 9. So now, the equation, that therefore means that the equation of the normal at x equals 2 is, let me write it, the equation of the normal at x equals 2 is given by, we know that normal passes through the point x equals 2, y equals minus 2. It passes through the point 2 minus 2. So that means its equation is given by y, this is the formula, y minus y1 equals m into bracket x minus x1, where here x1 is 2 and y1 is minus 2, while m is m2. So we can find the equation of the normal easily. So that means y minus y1, which is minus 2, equals m, which is m2 in this case, and it is 1 over 9. The gradient of the normal is 1 over 9 into bracket x minus x1, which is 2, which simply means y plus 2 equals 1 over 9 into bracket x minus 2. And I can write that as y plus 2 equals x minus 2 over 9. 1 times x minus 2 is x minus 2. when we do cross multiplication, that means 9 into bracket y plus 2 equals x minus 2. And that means 9y plus 18 equals x minus 2, which means 9y plus 18 minus x plus 2 equals 0. And that means 9y minus x plus 20 equals 0 is the equation of the normal at x equals 2. And that's it, very, very simply. We go to number 5. It says if y is equal to 2x plus 3 raised to the power 7 plus x minus 1 over 2x minus 1. Find the value of dy dx at x equals minus 1. First of all, let's differentiate. Okay, let k be equal to 2x plus 3 raised to the power 7. Now, this is a function of another function. So I want to put u equals 2x plus 3. That means k will be equal to u raised to the power 7, which means dk du is 7u raised to the power 6, and du dx is 2. And that therefore means dk dx, which is dk, no, that therefore means dk dx, which is dk du times du dx, is equal to 7u raised to the power 6 times 2. 7u raised to the power 6 times 2, and that is 14u raised to the power 6. So, which is equal to 14. We know that u is 2x plus 3. So that's 14 times 2x plus 3 raised to the power 6. That is dk dx. That's dk dx. So what we've done is I've differentiated this one. Now, that means dy dx, y is equal to, do I need to rewrite that? Let me just go to dy dx will be equal to the derivative of 2x plus 3 raised to the power 7, which is 14 into bracket 2x plus 3 raised to the power 6 plus the derivative of x minus 1 over 2x minus 1. To differentiate that, let's keep that. Let's do that. To differentiate x minus 1 over 2x minus 1, that's a quotient of two functions. Put down the bottom, which is 2x minus 1, differentiate the top. When you differentiate x minus 1, you get 1. Minus, put out the top, which is x minus 1, differentiate the bottom. When you differentiate this bottom, which is 2x minus 1, you're going to get 2 all over the bottom square. That's the square of 2x minus 1. So that's it. What we're going to have is, okay, let me just put that here. So when we differentiate that, we get 2x minus 1 times 1 minus x minus 1 times 2 all over the bottom square, which is the square of 2x minus 1. So the next thing will be, so now we have 14 into bracket 2x plus 3 raised to the power 6 plus 2x minus 1, when you open the brackets here, 2x minus 1 minus, of course, this is the same as saying minus 2 into brackets x minus 1, and that will be minus 2x plus 2 over the square of 2x minus 1. The square of 2x minus 1. This, the whole of this, is the same as minus 2x plus 2. So this is over the square of 2x minus 1. Now that simply means that's equal to 14 into bracket 2x plus 3 raised to the power 6 plus, of course, 2x minus 2x is 0, Minus 1 plus 2 is 1 plus 1 over the square of 2x minus 1. And that's dy dx, therefore. Dy dx is equal to 14 into bracket. Let me write it under it. Dy dx equals 14 into bracket 2x plus 3 raised to power 6 plus 1 over 2x minus 1 all square. 2x minus 1 all square. And that is it very, very simply. That's it very, very simply. That's it very, very simply. So, the question says find the value of dy dx at x equals minus 1. So I can say at x equals minus 1, dy dx will be equal to 14 into bracket 2 times minus 1 plus 3 raised to power 6 plus 1 over 2 times minus 1 minus 1 raised to power 2. And what do we have? That simply means 4 into bracket. 2 times minus 1 is minus 2. Minus 2 plus 3 is 1. 1 raised to power 6 plus 1 over 2 times minus 1 is minus 2. Minus 2 minus 1 is minus 3. 1 over the square of minus 3. And that's equal to 14 plus 1 over 9, which is 14 over 1 over 9. And that's 127 over 9. And that is dy dx at x equals minus 1. And that's it very, very simple. This is 127. And that's it very, very simply.